ए क्यों फाड़ रही हो? क्यों फाड़ते हो? मम्मी पिटेगी। और कोई और पिटाई करेगी, क्यों फाड़ रही हो तुम? लो ये खा लो।
Good evening, sir.
गुड इवनिंग युक्ता। Good evening, Pranav. Today we'll be starting with the new chapter, atoms and molecules. Is there a chapter, atoms and molecules?
Yes, sir.
Today we'll start with the new chapter in chemistry, atoms and molecules.
Okay, sir.
Yeah, good evening. And this week you have a test from bio.
Sir, we only have from bio.
Yeah, this week you have only bio test.
Okay, sir.
And that too from the chapter cell.
Okay, sir.
Okay, so atoms and molecules. Okay, so only two of you have joined. Just wait for 2 more minutes till everyone joins.
Okay, sir.
Okay. Okay. Jitendra also joined. Fine. So just 1 more minute. We'll be starting. We'll be starting at 9:05. All of you join quickly. So, okay, let's continue now. Let's continue. So see, this is your book which you are following. Just check atoms and molecules. And in this chapter, first we define what are atoms. Then we come to defining of molecules and other substances. So see, the discovery of the atom, it was done by a scientists few hundred years ago approximately. But the thinking idea of the atoms, like what are atoms actually? So the thinking idea of the atoms, it dates back a lot back. The thinking of the idea of atoms, it dates back to around 500 BC. So the evidences have been found with Maharshi Kanad. So Maharshi Kanad was an Indian philosopher. So philosopher means someone who is not performing the experiments, not recording the observations, but the person observes the nature and then put forward some ideas. Okay, so that person we call as a philosopher. So here an Indian philosopher that was who was Maharshi Kanad. So it was Maharshi Kanad who proposed the idea of atoms, and he called it as Parmanu, Anu and Parmanu. So how did the idea of atoms came up? The idea of atoms, it came up with the division of matter. Division of matter means if you have certain particles, so okay, let's see. So anything around us, whatever things we observe, and if we try to divide those particles into smaller particles or break those particles into smaller particles, okay. So what do you think? Do you think that we will be able to divide it at every time?
No, sir.
Yeah, okay. So whatever things we observe around us, if we divide them into tiny particles, okay. So whatever things we observe, anything, let's see here. So you can see anything around us. You can see books, you can see chairs, table, all the objects, whatever things you see around us. So those things, like here, you can see that there are different things which can be observed. You can see trees, plants, wood, glass, all are the different types of things which are available around us. And if I break it, okay, suppose I find some mechanism so that I can break it a number of times. So I'm now trying to break it a number of times. So a stage will come after which I will be able to get the particles of which it is made up of. I will be able to divide wood into particles of which it is made up of. Got it? So those particles of which the materials are made up of, those particles, they were called as padarth. In Hindi, that was by Maharshi Kanad. So those were called by. So what was padarth or atom? It is if we divide the particles. So divide the particles or break the particles or things. So if you divide the particles or things, we get tiny, undestructible. So they cannot be destroyed, undestructible particles. So we get tiny, undestructible particles, which can be, which can't be destroyed further. Okay, and these are the particles of which the wood is made up of. They are similar in their properties. So those are the particles which have been combined together to make up wood. In the similar way, you will get some type of particles which have been combined together to form leather. Got it? You will also see some types of particles which have been obtained combined together to form this. So this was the idea. And these particles, they were turned out or they were called as atoms. Originally, they were called as Parmanu, Anu and Parmanu. So Parmanu were the things which were called as atoms. So understood what are atoms? Later on, a few scientists studied and they found out, yes, there are some pure particles which cannot be broken down further. And those particles, they were called as atoms. Okay. So different studies were given about the atoms. So see first one, how the atoms are defined here. In modern terms, we defined atoms, the particles of matter which cannot be broken further. Okay. So the particles of matter which cannot be broken further, and the matter is made up of these particles. Of these particles. So these are the particles which make up the matter, which are making up that wood. These are the particles which are making up glass. These are the particles which are making up all these substances. So they are made up of atoms. Now atoms of the same element, they are similar in their they are similar in their masses and properties, whereas atoms of different elements, they are dissimilar in their masses.
Sir,
Atoms of similar elements. Yes, Lithika.
I just joined now, sir. Can you tell what you're teaching?
Okay, so we started with chapter atoms and molecules.
Okay, sir.
So in this chapter, atoms and molecules, we first define what is matter. So we have defined what is atom. Okay. So Yukta, can you tell what is atom?
So atoms are like these are the particles which cannot be broken down furthermore.
Okay, so atoms are the particles which cannot be broken down further. Yes. Okay. Okay, see the theory of the atoms. See, basic scientific study was carried out a few hundred years ago, but the idea of atom was always there. That it was always thought of that everything around us, whatever matter we see around us, is made up of tiny particles which cannot be broken down further. For example, if I break this wood into tiny, tiny particles, so even those can be broken down further, but at a stage will come after which it can't be broken down further. So those tiny particles which are pure, okay, of which your wood is made up of, so those tiny particles, they are called as atoms. Okay. Then it was a few hundred years ago that scientists started with the study of these atoms. They started maintaining records. They started recording their observations, everything. Okay. Now when the scientists started off, so initially it was Maharshi Kanad. The text find it as Maharshi Kanad who put forward the idea of atoms. Okay. Now around the same era, you also find a Democritus, Leucippus, all of them. They also suggested the idea of existence of the atoms. Okay. Atoms means meaning indivisible. So something which is indivisible, we call that as atom. Okay. Then see laws of chemical combination. So when the chemical studies were carried out, so the chemical studies carried out, it was started with Antoine L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. So these laws of chemical combination, they give a better hold on the idea of the atoms. Okay. So the two laws of chemical combination, they state the first one is the law of conservation of mass, a very prominent idea, a very old idea of the law of conservation of mass. So can you think what could it state? I think you have studied about the conservation. So now can you tell what would it mean conservation of mass?
Where it would state the atomic mass of particles,
The mass of
atoms.
the mass of atom.
Yes, yes.
No, see the law of chemical combination, the law of mass, the conservation of mass. So the conservation of mass, it states that law of conservation of mass, it states that the mass is conserved in a chemical reaction. Chemical reaction. So that means overall there is no loss or gain of mass whenever if you are performing any chemical reaction. So the mass of the reactants would be equal to the mass of the products. So it can be stated like this, stated as mass of reactant will be equal to the mass of products. So something like this it occurs. Law of conservation of mass. That means during a chemical reaction, you can't destroy or you can't change the mass of an object. Okay, so I think it has been moved. Okay, let's put it again. Law of conservation. Sampath, can you state the law of conservation of mass?
Then the law of conservation of mass states that the mass is conserved in a chemical reaction, and also the mass is obtained or lost during the chemical reaction.
Can you just be a louder?
Yes, yes, sir. Sir, the law of conservation of mass states that the mass is conserved in a chemical reaction, and also during a chemical reaction, the mass is neither lost nor gained.
Yeah, we can say the mass is neither lost nor gained. So the mass is neither lost nor gained during a chemical reaction. So during a chemical reaction, we find here that suppose if you have these substances as carbon and oxygen forming carbon dioxide. So this is a chemical reaction, carbon and oxygen combining together to form carbon dioxide. Suppose if you had 12 gram of carbon and 32 gram of oxygen. So the mass of carbon dioxide that will be produced will be 44 gram. Got it? Since the total mass of the reactants is 12 plus 32, which is 44, So the mass of the reactants must be equal to the mass of the products. Got it? Understood, everyone? So see, the next law is law of constant proportions. Now this is a very important law of constant proportions. So what is the law of constant proportions? It states that all molecules are made up of atoms combined in simple whole number by mass. Combined in ratio of simple whole numbers by mass. A simple example or idea of this is, suppose you study the formation of carbon dioxide. So from wherever you collect carbon dioxide, your carbon dioxide gas, it will always contain one atom of carbon and two atoms of oxygen. So that means their ratio, if you want to find out the ratio of carbon to oxygen or the mass of carbon to the mass of oxygen, you will always get the ratio something like this. So one atom of carbon, it makes a mass of 12 gram per mole, not one atom, sorry, this is the molar mass. Or if you want the mass of one atom of carbon, so it's 12 unit, and mass of two atoms of oxygen is 32 units. So if I find the ratio between them, it will be 12:32. So always your carbon dioxide will contain carbon and oxygen in the ratio of 3:8 by mass. From wherever you find carbon dioxide, from wherever you collect that carbon dioxide, you will always get carbon and oxygen combined in the ratio 3:8.
Well, it means that if we increase the mass of the carbon, then it increases gradually increases the mass of oxygen also.
What happened?
Sir, that means that if we increase the mass of carbon, then at the same time oxygen's mass also will increase.
Yes. If suppose somewhere you have carbon as 36 gram, okay. You have carbon as 36 gram or carbon as 24 gram, so oxygen will be 64 gram.
Okay, sir. Sir, means
Just 1 minute, 1 minute. Hold on. हेलो बेटा, अभी मैं क्लास ले रहा हूँ, डिस्टर्ब मत करो, अभी नहीं बात करा पाऊंगा. We can continue now. So it will always be maintained in this ratio.
Sir, means different molecules have their own different ratios.
Yeah, for example, suppose if you have water, okay, so what will the, can you tell me the ratio of hydrogen and oxygen?
Sir, two hydrogens and 2:1.
Okay. No, that number, we are not talking of number. We are talking in terms of the masses. Okay. So mass of hydrogen, if you will have 2 units of hydrogen, then you will get here 16 units of as mass of oxygen, which is the atomic mass of oxygen. The atomic mass of oxygen is 16 and the atomic mass of hydrogen is 2. Okay, so it will always be present in the ratio of 2:16, and if you find out the ratio simplified, it is 1:8. So hydrogen and oxygen will always be present in the ratio of masses as 1:8. If you have 1 gram of hydrogen, you will have 8 grams of oxygen. If you have 3 grams of hydrogen, then you will have 24 grams of oxygen in water. Got it? So, like it's if you somehow break water, okay, so you will obtain hydrogen and oxygen in this ratio. The masses of hydrogen and oxygen, it will be in the ratio of 1:8. But this is called as the law of constant proportions. Okay, try to find out the ratio for this. NH3, carbon monoxide, hydrogen peroxide. Try to find out the ratios here. And just I'm coming in 1 minute. Try to find out this, all everyone. Okay, so have you got the ratios here? Yes. Shravan? Yes. Any help? Do you need any help in finding out the ratios of their masses?
Yes, sir. Yes, sir. I need help.
Okay. So see, if you want their atomic masses, so I give here the atomic mass of nitrogen is 14. Nitrogen has atomic mass 14. Okay, I list you here their atomic masses. Some of the elements I list the atomic masses here. For hydrogen, the atomic mass is 1. I'm writing atomic masses. It's 1 unit or 1 atomic mass unit. So hydrogen is 1, helium is 2, helium is 4. Then you have carbon as 12, nitrogen 14, oxygen 16, chlorine 35, sodium 23. Okay, is there anything else that you need out beyond this?
No, sir.
Okay, calcium is 40. So I have given you to find out the ratio between of carbon monoxide NH3 ammonia. You can also find out the ratio for calcium oxide, and let's say this one H2O2 hydrogen peroxide. Now can everyone find it out? Can everyone find it?
Yes.
Jitendra, did you get the answer?
Doing so.
Jitendra is very perfect name. So Jitendra will be able to answer. Sampath, yeah, what happened? Sampath,
Sir, nothing, sir.
you raised the hand. So have you done?
Yes, sir.
Okay. But I want the answer from Jitendra. Jitendra means winner. Yeah, Jitendra, what's your answer?
So CO is
Yeah.
3 to
Jitendra,
4.
can you tell the ratio for carbon monoxide?
So 3 to 4.
3:4. Okay. So for this you get 12:16, and this will be equal to 3:4. Right. Okay. Sampath, what is the ratio for NH3? What is the ratio for NH3?
Sir, 14:3.
14 is to
Sir, 3.
3. Okay. So it is 14:3. For calcium oxide, for this one it's 14:3. Okay. For calcium oxide, still the Sampath hands are there. Yukta,
Sir, is
yes.
it 5:2?
How much?
5:2.
5:2 for calcium oxide.
Yes, sir.
Okay, let's check it. So for calcium oxide, we are obtaining here 40:8. So 40:16.
Yes, sir.
And 40:16 simplified as 2 ratio. So not 2.
Sir, I got 10:4.
10:4 can still be simplified.
Yes.
Simplified still further. Even if you get 10:4, so you can simplify it to obtain 5:2. Okay. Then what is the ratio given for H2O2?
So 1:16.
Yeah. For H2O2, the ratio is 1:16. So it means that from wherever you obtain these chemicals. Okay, so from anywhere you can obtain carbon monoxide. And if you observe this, so you will always find carbon and oxygen in the ratio of 3:4 by mass. Okay. Got it? So shall I give you some more chemicals to find it out?
Yes, sir.
Okay, find out for NO2, nitrogen dioxide. Find it for CH4, methane. C4H10, which is butane. Find for NaCl. Yes, find this all.
Sir, what is CH4, sir?
Yeah, Sampath, what happened?
Sir, what is NO2 and CH4?
Na.
Sir, what is NO2 and CH4, sir, their names?
Okay, NO2, its chemical name is nitrogen dioxide. It is nitrogen dioxide. And CH4 is called methane. Methane gas. Okay, just 1 minute. C4H10 is butane. Okay, just give me 1 minute. Just give me 1 minute. Okay, try out for all of them. Try out for all of them. I'm coming in 1 minute. Just try for it. Okay, so who all have obtained it? Who all have obtained it? So I think everyone is doing. Okay, Harshit has done. Harshit means happy. One who is always
Sir.
happy. Okay. So Harshit will tell the answer for the first one.
Sir, 7:18.
7:18. Just check for oxygen again. Is there anyone who obtained the same answer?
Sir, 7:8.
7:8.
Sir, I got 7:16.
7:?
So 7:16.
Yeah, it is 7:16 here. So here you obtain the ratio 7:16. Okay. Now Sharwan will tell for CH4. Sharwan, tell the answer for CH4.
Sir, is it 12:1?
What is?
12:1.
12:1. No, it's 12:4. See, how many hydrogen atoms are there?
4.
4. And the mass of one hydrogen atom is 1. So mass of 4 hydrogen atom will
Okay,
become
sir.
4. Got it now? So
Yes, sir.
there is just one carbon atom and mass of one carbon atom is 12. The mass of 4 carbon atom will be 4. So now you simplify it and you will get the simplest ratio. Okay, Sharwan will only tell the answer. He knows the answer. Yeah, Sharwan, what is the ratio that you get now?
3:1.
3:1. Okay. So you get the ratio 3:1. Okay, obtain for this one C4H10. Now let's say whom I have not asked. Okay, so Jitendra, Pranav. Pranav will answer. Pranav has not answered even single question. So Pranav will answer this. Pranav? Yeah, Pranav? Pranav, are you there? Pranav is not responding, so Pranav's name will be highlighted. I think he has gone to take a break. Pranav? Okay, so this will be answered by now Yukta. Yukta, answer this.
So just a second. Sir, how do we take when we have like 4 atoms of carbon and 10 atoms of hydrogen?
So see, you have to take it like this. It's C4H10. Okay. So there are 4 atoms of carbon, and from the list I can say that atomic mass of carbon is 12, atomic mass of hydrogen is 1. So the mass of 4 atoms of carbon will be 4 multiplied 12, and the mass of 10 atoms of hydrogen will be 1 multiplied 10.
Okay, sir, got it.
Okay. So 48 ratio 10. Now you simplify this ratio of 48 ratio 10. So it can be simplified
So
as
24 is to 5.
how much?
24 is to 5.
Yeah, the ratio is 24 ratio 5. The ratio of carbon to hydrogen, you will find 24 ratio 5 for C4H10. This is butane. Okay, now find out for this also. C2H2. Hands up. Okay, obtain the answer for C2H2.
So is it 12 is to 1?
12 is to 1. Yes, it is 12 is to 1. So now is there anyone who is finding still difficulty in finding out the ratios?
No, sir.
Okay. So Jitendra, which law of chemical combination are we doing? Jitendra, what is the name of the law of chemical combination which we are studying? Jitendra?
Yes, sir. Yes, sir.
Which law of chemical combination are we studying? We are studying. Okay, anyone who can answer? Likita, can you answer which law of chemical combination are we studying? See, here we are doing the law of constant proportions. See, We are doing the law of constant proportion, and the statement of the law of constant proportion is in a chemical substance, the elements are always present in definite proportions by mass. Okay. So in a chemical substance, the elements are always present in definite proportion by mass. Got it, everyone?
Yes, sir.
Yes, sir.
Okay, just take this question. I think everyone should be able to do this question. Let's see. Okay, so obtain this answer. Just go through the first question. Yes, go through the first question. In a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. The products were 2.2 gram of carbon dioxide and 0.9 gram of water and 8.2 gram of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. So the reaction is also given to you. You can take it. Anyone able to answer this? Okay, see how you will answer this. The reaction is given here, so we rewrite the reaction. The reaction becomes sodium carbonate plus acetic acid. Then you obtain sodium acetate. The products are sodium acetate plus carbon dioxide plus water. And if you see, the quantity is also given. Sodium carbonate is 5.3 grams. So you get here 5.3 gram
So
of
11.3.
yeah,
So we need to add, right? 11.3.
yeah. So you get 5.3 gram of sodium carbonate, 6 gram of acetic acid, and here the sodium acetate that is produced. The products are 2.2 gram carbon dioxide. So your carbon dioxide is 2.2 gram. Water is 0.9 gram. So this water is 0.9 gram, and sodium acetate is 8.2 gram. So you have to check whether these observations are in accordance with the law of conservation of mass or not. Okay. So add all the masses of the reactants. Sampat, what is the mass of all the reactants?
Sir, 11.3 grams.
Yeah,
Sir, 11.3 grams.
11.3. So mass of the reactants, it becomes 5.3 plus 6, which becomes 11.3 gram. Okay. What is the mass of the products?
Sir, same 11.3 grams only,
So
sir.
11.3.
11.3. So what will be our answer? Yes or no?
Yes, sir.
Sir, yes.
Yes. So we will add all of them. We will add here 8.2 plus 2.2 plus 0.9. So you can add all and you still get 11.3. Okay. So is this in accordance with the law of conservation of mass?
Yes, sir.
Yes. So yes, it is in accordance with the law of conservation of mass. Can you okay, try out the next one? The next one is from the second one, law of constant proportions.
So is it 24 grams?
Yeah?
Sir,
So
the mass
24
of
grams.
oxygen is 24 grams.
So see, hydrogen and oxygen, they combine in the ratio 1:8 by mass to form water. What mass of oxygen would be required to react completely with 3 grams of hydrogen? So is the answer 24 gram? Yes. See, you will be solving this question something like this. You will put the ratio hydrogen to oxygen. The mass ratio is 1:8. And currently we have 3 gram of hydrogen. We want the mass of oxygen. Let's take it as X. So you will obtain X equals to 24 gram. That's the answer. Okay, for the same question, can you find out how much mass of hydrogen is required if I take 2.4 gram of oxygen? Yes, find it out that how much of hydrogen is required if I take 2.4 gram of oxygen. This is your homework. You need to find the mass of hydrogen required to combine with 2.4 gram of oxygen. Okay. Bye all of you. See you again in next class.
Thank you, sir. Bye.
Okay.
Thank you. Bye.
Sir, bye, sir.